Hey, this is Mr. A. I am going to give you a little mini lesson on significant figures and scientific notation, and this is going to be a little mini lecture that you're going to find really, really useful, because I know a lot of you were frustrated with, I showed a video and there was this one, it was like the decimal point and these zeros, and you really didn't know if those numbers were significant or not. I want to handle a few of those examples that caused you trouble, and I'm going to show you how to make it so that they're not going to cause you any trouble anymore. So really all I'm going to do is I'm going to put 4 examples here, and then you're going to summarize your notes right here. The first example, I'm just going to put up a number, say this is a measurement of 10.1. I want you to tell me how many significant figures is that? Go ahead, shout out.
3.
3. Yeah, that's a pretty easy one, okay? Now, let's use our skills in converting into scientific notation. What would this number be in scientific notation? Somebody else.
1 times 10 to the 1.
Scientific notation, we always have 1 digit to the left of the decimal.
There's
So
no point.
it'll be
1.01.
1 to
Times
negative
1
1.
to the negative 1.
Yeah. So the process that you're using in your head, just let me speak it out loud so that you hear it. This number is greater than 1, so it's going to be a positive exponent. You're going to move that decimal over to the left. So you're going to move it over to the left 1 digit, right? So it's 1.01 times 10 to the 1. Is that what you guys said?
Yes.
I think that's what you did say.
You said negative.
Okay. So this was example number 1. All right. Example number 1. Example number 2. I want to put another number up here. This one might have given you a little bit of trouble. 0.0012. All right. Drew, how many significant figures is in 0.0012? 2. Very good. Because you know these are placeholder zeros, and these are the only non-zero numbers that are significant, right? So this one has 2 significant figures. Now, Luke, how would you write this number in scientific notation?
So, is it 1.2
So there's always 1.2 and then times 10 to the...
to the negative 2?
Yeah, so you're looking at this, and let me just think out loud. This is how you attack this problem of converting it. This is a number that's less than 1, so you know that your exponent is going to be negative, and so now you're going to be moving the decimal point over to the right. So it's going to be a negative exponent. It's going to be
Negative
1, 2, 3 times 10 to the negative 3. Okay? So this is that number in scientific notation. All right? We're going to do another example. This is one that was in the video, and I had a lot of people ask me questions about this one. 6900 point. Okay? Alan Rango, how many significant figures are in this?
There are.
A lot of people wanted to say 2.
I know there's a point involved. So
But there's a decimal point
four.
involved, and so that makes these 2 non-zero numbers significant. So we actually have 4. And I think I said in the video, if I remove that decimal point, then there is only 2. But since that decimal point is here, what the person who made that measurement is trying to communicate is that, hey, there's a decimal point there. This is really that measurement. So just like we talked at the beginning of class with Johanna, she wrote the 2, but she really meant 2.0. She didn't write it, so we didn't know, so we didn't have that to work with. But if there is a decimal point here, that's going to make all those significant. All right? Lainey, what is this number in scientific notation?
6.9 times 10 to the 3rd.
Okay, so this is a number that's greater than 1, so we're going to have a positive exponent. We're going to move the decimal point over to the left 1, 2, 3 places, because we can only have 1 digit to the left of the decimals. So that is 6.9 times 10 to the 3. Now, here's a problem. You said that there were 4 significant figures right here, but you just left off 2 of them when you wrote this. Right? So when those numbers are shown as significant figures and you're converting it to scientific notation, you have to keep those numbers there, or else you just wipe out the significance of their measurement. So you need to keep those zeros in there. All right, one more example. All right, and I'll answer questions at the end of the presentation. 1, 2, 3.400. Think about that for a minute. Maybe you could, hey, stop the video and see if you can answer what the number of significant figures is on that one. And then, hey, if you got a little more time, why don't you try to convert it to scientific notation? Okay, Brandon, how many sig figs here?
4. No, wait, no. 6.
So Brandon's having an argument with himself. I see these non-zero numbers, they're definitely significant. And then I've got these trailing zeros and you're arguing with yourself. Now are those placeholding zeros or did the scientists really mean to include those numbers there? When you see trailing zeros to the right of the decimal point, they are significant. The scientists meant to have those there. Okay? So we need to count those. So it's not 4, it's actually 6. Okay? And then Delwyn, what is this number in scientific notation?
Is 1.23400 times 10 to the 2.
Yes. Very good. Okay. Now, I'm going to make your life wonderful. 3 significant figures in example 1. How many digits do you see before the times 10 to the thing? 3. 2 significant figures here. How many numbers do you see to the left of the times 10 to the thing?
2,
2. This one here, how many numbers do you see?
4,
That's how many significant digits there are. This one here, how many do you see?
6.
6. So when you write your number